Here is a question from Gate 2020 Chemical Engineering. So in this question we have been given a PV relationship and a relationship for residual molar Gibbs free energy in terms of compressibility factor. We have been asked to calculate residual molar enthalpy. So now let us see the solution to this question. So from the given PV relationship we can obtain the compressibility factor as 1 plus BP by RT. So that Z minus 1 would be BP by RT. So using this expression in the given relationship for residual molar Gibbs free energy, we obtain GR by RT as BP by RT as per equation 1. So now let us try to relate residual molar enthalpy to GR by RT, so that using equation 1 we can get the final answer. So from the fundamental thermodynamics relationships, we are aware of the fact that G is nothing but H minus Ts and dG is nothing but VdP minus SdT, which comes from first law of thermodynamics. And we know that the residual property would be the difference of actual property minus ideal gas property. So equation 4 is an expression for residual Gibbs free energy. So since we have all the expressions in terms of G by RT, let us see what's the total derivative of that term would end up being. So considering the differential of G by RT, we would get derivative of G by RT as dG by RT plus G into minus 1 by RT square dt as per equation 5. Now substituting equation 2 and 3 in equation 5, we get the total derivative as VdP by RT minus SdT by RT minus H by RT square dt plus S by RT dt. So since we have two like terms with opposite signs, we can cancel these two. And we end up with the final expression as dG by RT to be equal to VdP by RT minus H by RT square dt as per equation 6. So now let us extend this equation 6 to an ideal gas so that we obtain an expression dG ideal gas by RT to be equal to V ideal gas dP by RT minus H ideal gas by RT square dt as per equation 7. So as per the definition of the residual property, if we take the difference of equation 6 and 7, we would get dGr by RT as VR by RT dP minus HR by RT square dt. So at constant pressure, we can write this above expression as dou Gr by RT by dou T at constant pressure with a negative sign to be equal to HR by RT square. So now we have successfully related residual molar enthalpy with Gr by RT as per equation 8. So now from the obtained relationship for Gr by RT, we can get an expression for dou by dou T at constant pressure for Gr by RT with a negative sign as minus BP by RT square as per equation 9. So from equation 8 and equation 9 we can get residual molar enthalpy as BP. So we have been given that B to be equal to 1 into 10 power minus 4 meter cube per mole and P is 1000 kilopascal. So the final answer for residual molar enthalpy would be the product of these two terms. And since we require the solution in joule per mole, we will have to convert pressure to Pascal from kilopascal. So the final answer would be 100 joule per mole. So the solution to this question is option A, 100 joule per mole.